All right, we are talking about 7.2, which is exploring similar polygons. Makes it sound real fancy, but okay. So two polygons are similar if two things are true. So I'm going to show you two similar polygons, and then you kind of tell me what you think about it. Okay. So if I told you that quadrilateral ABCD is similar to EFGH, so for similar, what they do is they use the congruent sign, but they take away the equals. Because are these two congruent? No, this one's bigger. But they aren't just two totally different shapes, are they? No, it's the same. One of them is just a stretch or a shrink of the other one, right? That's called a dilation. When you take a shape and you either stretch it or shrink it, that's called a dilation. So is AD congruent to EH? Are those two sides congruent? No, but they correspond to each other. And so what you find is that they are in the same ratio. So if I told you this was 10, and this was 5, this was 8, this was 4, this was 6, this is 3, this was 5, this was 2.5. Do you see a pattern or something that's happening?
It's half of each.
If you multiply this by half, you'd get that. If you multiply this by half, you get that. So what happens is all the sides are in the same proportion. So if you did AD over EH, what would you get? That'd be 10 over 5, which is 2, right? If you did DC over HG, you would get 8 over 4, which is 2. If you did BC over FG, you would get 6 over 3, which is 2. And if you did AB over EF, you would get 5 over 2.5, which is also 2. So what do you call it when everything is the same ratio? When the ratios are equal? Do you remember? It's funny because I was actually just teaching this in my pre-algebra class, but something totally different.
Repeat the question.
What is it called when the ratios are equal? When you have two ratios equal to each other. That's what last section was. You got no?
This.
Proportion. Okay. Two ratios are equal, it's called a proportion. If you have fraction equals a fraction, that's proportion. Okay? So, similar polygons. If polygons are similar, two things have to be true. The sides must be proportional, which we talked about. Proportional just means always the same ratio, right? And that ratio is called the scale factor. Okay? If proportional, ratio, because it's the same every time, is called scale factor. Because you can see why 2 would be the scale factor. If you multiplied everything by 2 over here, you would get that, right? So the sides are proportional. What about the angles? Is angle A double the size of angle E? Think about it. If I were to copy angle E, yes. Okay, it's right there. So if you copied angle E and move it over here, it looks exactly the same, right? Because the angle is just how far is it from there to there. And that's the same, right? What about angle D and angle H? They're exactly the same, right? What about C and G? They're the same. Well, it does matter how long, and that's another way to mark those. So if the polygons are similar, the length of the sides have to be in proportion, and the angles, corresponding angles, must be congruent. So for right now, the only way to prove two polygons are similar are to show those two things. Now, if you'll remember back when we first learned what congruent triangles were, when I told you what congruent triangles were, you knew that two triangles were congruent. It meant that all the pairs of sides were congruent and all the pairs of angles were congruent, right? And so I don't know if you remember, but there was one day where the only way you could prove two triangles were congruent is you had to prove all 6 things. You had to prove all 3 pairs of sides were congruent and all 3 pairs of angles were congruent. And if you did that, then you could say the triangles were congruent. But then the very next day, we learned that it wasn't necessary to prove all 6 of them. You could do side, side, side. Just prove those 3, and that would be enough. You could do side, angle, side. Just prove those, you see. And so the same is true for, well, for polygons, this is always true. The only way to prove two polygons are similar is you have to show all corresponding sides are the same proportion or same ratio, and all corresponding angles are congruent. But if we break it down into, we're just talking about similar triangles, which is where we're going to end up, then you'll soon learn, and I think starting tomorrow, you will learn that you don't have to prove all those things. You don't have to prove all 3 pairs of sides are proportional and all 3 angles are congruent. You can prove smaller things if you prove the right few things, okay? But for today, the only way to prove two polygons are similar is if you show every side is proportional and every pair of angles is congruent, okay? Now, if you were just told they're similar, like you are here, then you know all this. You know the sides are proportional. You know the angles are congruent, okay? So, we're only going to do 2 examples here. All right, so I'm going to tell you RSTUV, this is example 1, is similar to polygon A, B, C, D, E. Okay, I'm going to ask you 2 questions. All right. While y'all catch up writing that, let me find and plug in my computer. Okay. So it's always important to know, are we told they're similar and we're solving some problems, or are we given some information and trying to prove that they're similar? So which is true here? We're told that they're similar, okay? So since they're similar, what do we know about the sides? What do we know about the angles? The sides are proportional and the corresponding angles are congruent. So they didn't tell us this, but if we knew angle R, if I told you angle R was 100 degrees, what would you know? Angle A is also 100 degrees, okay? And the order it's written is important. This lets you know, since R is first here and A is first here, that R corresponds to A. That segment RS corresponds to segment AB, and so on, okay? So we know angles are congruent, but that doesn't help us because we weren't asked about the angles here. But we also know sides are proportional, and that proportion is called the scale factor. So to know the scale factor, we need to know two corresponding sides. So is there a pair of corresponding sides that we know on both polygons? Sorry? No, because we don't know what x is yet. If we knew what x was, then we would know RV and AE, but we don't know what x is yet. If we knew those, they are corresponding, but I'm saying which two are corresponding that we know what they are?
Oh, ST and BC.
Right. ST and BC. So the scale factor is just going to be ST over BC, which is 18 over 9, or that's a 4, sorry. That needs to be a 4. 18 over 4. So change that both places. I copied the book wrong. Okay. So 18 over 4, which 2 goes into both of those, and you get 9 over 2. So that's the scale factor, which means 9 on the big shape corresponds to 2 on the small. To see, that is 2 9s, that would be 2 2s. So 9 over here is 2 over here. Okay? So the scale factor is 9 over 2. So now, how would you find x? Well, all the sides, corresponding sides, are in the same proportion. So you could say, we're always going to use these two because these are the ones we know, right? So we could say, whatever ST over BC is, that has to be the same as RV over AE, right? This over this has to be the same as this over this. So ST is 18 over BC is 4. Keep wanting to make that 9 for some reason. RV is X over AE is 3. So how would we solve it? Yeah, now I would reduce this first and say 9 over 2 is X over 3. Cross multiply, you get 2x equals 27, so x is 13.5. Or you said 27 over 2, that would have been fine as well. Okay, how are we going to find y? Well, for y, we're going to use the 2 we already know, and this and this. So we could say ST over BC is the same as UT over DC. This over this is this over this. So that is 18 over 4 equals y plus 2 over 5. Now that again reduces to be 9 over 2 is y plus 2 over 5. What is 2 times y plus 2? I'll leave it like that for now. 9 times 5 is 45.
Also distribute.
You distribute, that's 2y plus 4 equals 45. So 2y is 41. So y is, you could either say 41 over 2 or 20.5. That's your answer. Okay? Everybody good? All right. Let's do one more example. And really, that's it for this whole section. And this is like an example in the book, but I'm changing just a few things. Okay? Okay. Well, let's look at what we have. So A is 0, 0. B is 8, 0. C is 2, 7. So we've got triangle ABC. Okay. Then we've got D is 16, 0. And E is 4, 14. Okay. So you see what you have here. You have A, B, C that looks like that, and you have A, D, E that looks like that, right? Okay. So this would be A is 0, 0. This is 8, 0. This is 2, 7. This is 0, 0. This is 16, 0. And this is 4, 14. This is A, B, C. This is A, D, E. Okay. So what do we have to show? I'm going to label the angles just so that we have easy. So this would be 1, 2, 3. This would be 1, 6, and 7. Okay? What do we have to show these two triangles are similar? What two things have to be true? All sides have to be proportional. All angles have to be congruent. Okay? So first, are the sides proportional? So what we need to do is figure out AC over AE and see what that is. Then figure out AB over AD, see what that is. Then figure out BC over DE and see what that is. And if they're all the same ratio, then they're in proportion, right? Well, let's just figure out first the measure of each one. What is AB? You can either count or use the distance formula. What is the distance from A to B? 8. We have 8. Okay. What is BC? Now that's not one we can count, right? We got to use the distance formula, which says it's the square root of the difference in the x's, 2 minus 8 squared, plus the difference in the y's, 7 minus 0 squared. So that is the square root of negative 6 squared is 36, plus 7 squared is 49. So that is the square root of 85. Now 85 is 5 times 13, so nothing, you couldn't take the square root of anything and bring it out. That's as simple as it gets. Okay? Well, what about, so we've got AB, we've got BC, we need AC. So how would we do AC? Distance formula. Difference in the x's squared, 2 minus 0 squared, plus the difference in the y's squared, 7 minus 0 squared. That is 2 squared, which is 4, plus 7 squared, which is 49, which is the square root of 53. So, (53) is a prime number, so that's just the square root of 53. So we've got A, we got B, AB, we got BC, we got AC, right? So we need to find all three sides of the other one. So AB on this one, so this would be BC is the square root of 85, and AC is square root of 53. Okay, what would correspond to AB on this triangle? What on the big triangle would correspond to AB? It would be AD. Now what is AD? That's one you can just count. It's from 0, 0 to 16, 0. So it's 16. If you forgot that, you could use the distance formula. It would be fine. What corresponds to BC on the big triangle? DE. That we're going to have to use the distance formula. Square root of difference in the x's squared, 4 minus 16 squared, plus difference in the y squared, 14 minus 0 squared. That is 144 plus 14 squared is 196. So that is the square root of 340. Well, 340 happens to be 4 times 85. So what's the square root of 4? 2. So this DE is equal to 2 square root 85. 2 square root 85. Okay. The last one we need AE. Going to need to use the distance formula. Square root of difference in the x's squared, 4 minus 0 squared, plus difference in the y squared, 14 minus 0 squared. That is the square root of 4 squared is 16, plus 14 squared is 196. That is the square root of 212, which happens to be 4 times 53. So what's the square root of 4? So this is 2 square root of 53. So when we find AB over AD, that is 8 over 16, which equals 1/2, right? Then when we find BC over DE, that is square root of 85 over 2 square root 85. Well, that is 1/2. Then when we find AC over AE, that is square root of 53 over 2 square root of 53. That is 1/2. So what does that mean? All corresponding sides are proportional. Okay? Well, what is the only thing left that we have to prove? What two things are true for similar polygons? All sides are proportional, all angles are congruent. So we need to show all pairs of angles are congruent, right? Well, one of them is really easy. Angle 1 is congruent to itself by reflexive, right? And that was on both triangles. Okay? How could we show 2 is congruent to 6? Well, if these two lines were parallel, would 2 be congruent to 6? If these two lines were parallel, 2 and 6 would be corresponding angles, right? Two parallel lines cut by a transversal, those are corresponding angles, right? So we have to prove that they're parallel. So let's find the slope of BC. Slope is change in y, 0 minus 7, over change in x, 8 minus 2, that is 7 over 6. Wait, negative 7 over 6, sorry. Okay? Then find the slope of DE. That is change in y, 0 minus 14, over change in x, 16 minus 4. Well, that is negative 14 over 12, which is negative 7 over 6. So what does it mean that the two lines have the same slope? They're parallel, so BC is parallel to DE. And since that is true, we could say angle 2 is congruent to angle 6, because if parallel lines cut by transversal, corresponding angles are congruent. So what's the only thing left? We've shown 1's congruent to 1, we've shown 2's congruent to 6. We need to show, yes, 3 is congruent to 7. And there's actually two ways you can do that. Do you remember that we had a theorem that says if two angles of one triangle are congruent to two angles of another triangle, the third angles have to be congruent. So that's one of them. Two angles of this triangle congruent to two angles of this one, the third one has to be congruent. So you could say that if two angles of one triangle are congruent to two angles of another, then third angles are congruent. Or we've got two parallel lines cut by a transversal. Those are corresponding angles. Or you could say if parallel lines cut by transversal corresponding angles congruent. Either way, we've now shown all three pairs of angles are congruent. All three pairs of sides are proportional. So, yes, the two triangles are similar. And that's it. Okay? So the only way to prove two triangles are similar is all three pairs of sides have to be proportional and all three pairs of angles have to be congruent. And then that's it. Okay? All right. So your homework is it's on the board, but page 351 through 352, 13 through 32, all. It's not odd this time because there just weren't that many practices, so I didn't think odd was enough for y'all to really get it. Okay? So y'all have the rest of class today to either work on this or ask me questions from your 7-1 homework. You have a quiz Friday on 7-1 and 7-2. Now we're covering 7-3 tomorrow, but it will not be on the quiz.